The plots that you generate in Plotly can be browsed online. They can be stored as an offline HTML5 file, and they can also be displayed inside a Jupyter notebook. So we're going to do the latter. In this course, if you want to try running Plotly yourself, you have a number of options. You can actually install Python 3, and then Plotly and Jupyter on your notebook. And I'm not going to provide instructions on how you do that. You can Google it, but that's one of the options. We also have Plotly installed on our training cluster. And in a minute, I'm going to show how we can run it. And then you can spawn a Jupyter Hub instance through the web browser. And you can actually run Plotly right inside the web browser. You can also log in to the training cluster and use Plotly in the command line. It is installed there. But that will create an HTML5 visualization, a file that you will need to download to your laptop. You can also use Plotly inside Google Colab notebooks. But to do that, there's actually a little bit of work involved. So if you want, you can do that, but that's not the option I recommend. Also, one of the options could be going to syzygy.ca and logging in with either a university ID, or you can log in with your Google ID. Let me show how you can run Plotly using the training cluster. I'm going to click on this link, cassiopeia.c3.ca. Here it is. Here, I log in as user120 using my password to the training cluster. Please use your own guest accounts to log in here. So I click on sign in. And here I will use this interface to start an interactive job on the training cluster. Inside that interactive job, I will run Jupyter Hub, and then there I can start a new Python 3 notebook. So here I'm specifying time, let's just stick to 1 hour. Number of cores is 1. Memory, 1024 megabytes. And this is really important. You want to enable core over subscription so that multiple people can use the same processor at the same time. There are no GPUs, and then user interface, just use the default Jupyter notebook. I'm going to click on Start. And that starts the Jupyter Hub instance. So right here, I can click on New, and then Python 3. And here I can type in the Python code. So let me show you a few examples. These I'm going to paste from the website, which is linked from the course webpage. So I will go to the chapter called Plotting inside a Jupyter notebook. And here I'm going to paste a very simple code. And then I will run it. I hit Shift Return, and it runs, and it creates a one-dimensional plot. So let's briefly take a look at the code itself. First, we are importing the module called offline from the Plotly library, and we give it an alias pi. Then we specify the notebook mode. We set it to connected. And what this means is it will use the online plotly.js library right inside the notebook. So that means that the notebook itself is going to use a little bit less memory and a little bit less CPU resources to run on the training cluster. I import another module graphs object from Plotly library and give it an alias go. Then from NumPy math library, I import linspace and the sine function. I create a discretization with linspace. And here I have 100 points going from 0.01 to 1. Let's print what x1 is. You will see that it is 100 points linearly distributed between 0.01 and 1. And then for each of these points, I calculate the value of sine function so that x1, so that y1 is actually the value of the sine function at that point, and all the arguments are in radians. So here I have two vectors, x1, two NumPy arrays, x1 and y1, and then I call the scatter function, to which I pass the arrays x1 and y1. These are going to be used as the x and y coordinates of all the data points. And then the line mode is lines plus markers, so you actually see both dots and the lines connecting the dots in the plot. And then we give the name of the plot. So this name doesn't show in the plot because we have just single line. But if you have multiple lines in the plot, then besides each line, you will see the name of the corresponding plot. So we created this trace object, which is actually a Python dictionary. So let me print it. I'm going to say trace1, shift return. And so this is the Python dictionary that simply contains all the arguments that I passed to it. So there is a list of x coordinates of all points, there is a list of y coordinates of all points, then mode, and then the name of this plot. And that's it. So there's no plotting yet, right? I just created Python dictionary. And then I create an object called data, which is a list of the Python dictionaries that I'm going to plot. It's a list of all elements in my plot. And then I call iPlot from Plotly offline that simply plots my data. So now if I want to create two plots, what I can do is I will create another object. I can call it, for example, trace2. And then to data, I will pass a list of all objects. And it will be trace1 and trace2. And then I'm going to plot the data object. Let's create a slightly more complex plot. I will paste the code from the heat maps section. And let me hit shift return so that it plots. And what you can see here is the plot of temperatures, so record low, average low, daily mean, average high, and record high for each month, and then for the year as well, for one of the weather station in Antarctica. It's a heat map, so each value is displayed with a color on the scale given by the legend or the color map on the right. And all I need to do here is basically create a few objects. So here I create the list of months, and then I create the lists of record high, average high, and so on temperatures. Then I create a heat map to which I pass all the lists that I just created containing temperatures. The x-axis will contain the list of months, and then the y-axis contains the labels for record high, average high, and so on. Then I create the data object to which I pass my trace. Data contains the list of objects that I'm going to plot, and then I plot data, and that creates a nice heat map. Now let's create a geographical scatterplot. I will paste the code from the online nodes. And here what we're plotting is population for about 200 plus or so Canadian cities and towns. So let's just take a brief look at the code. Here I'm importing pandas data frames as PD. I read the data file. So when you run this on the training cluster, data is taken from this file that I uploaded a few days ago to the cluster. I also included this file into the zip download in the data folder. You can find it in the same zip file that contained the slides. Here I create a new column in the data frame that will contain the text for each data element. So when I mouse over a city or a town, a pop-up will come up containing the name of the city or town, its population, and some other information. And so this column contains the text for that pop-up. Then I declare the smallest and largest populations, which are simply the mean and max functions. I'm applying the mean and max functions to the population column in the data frame. I normalize the data so that everything is between the smallest and the largest population. And then I create this cities object that has the longitude, latitude, the text label for each city, and then it will be displayed with a marker, basically with a circle. I set its size, its color. I declare the color scale using the Viridis map and show the color bar on the right. And this is the line that will be used in each circle. So I declare its width and its color in RGB. And then size mode area means that the logarithm of the population will be encoded as an area, not as a radius. And then I create this layout object. So the layout essentially tells Plotly how to plot things. So for example, scope North America means that everything will be placed on a North American map as opposed to a world map, for example, or European map. Resolution 50, so that's the resolution of the map. And then how you show, various objects like rivers, lakes, etc., etc. So true means that they will be shown, and then I also supply the color. So I have these two objects, series and layout, and then I create a new object called figure. So Go is one of the modules in the Plotly library. So I say Go figure, and then to it I pass my data object, which is the list of all objects that I want to plot. So it contains a series object, and then I pass layout, and then I plot this figure, and this is what you get. So this is an interactive figure. You can actually zoom in and out. You can pan it around in the plane of the screen, and then you can mouse over any city or town, and that will give you its name, its geographical coordinates, and the population in million. Next, let me show you a three-dimensional plot in Plotly. So in Plotly, you can create very simple three-dimensional plots. You can spin them in 3D. You can zoom in and zoom out, but they're not really truly interactive like the plots you will get with ParaView. So this is much simpler three-dimensional plotting. Let me run this code. And this code reads the elevation data, so landscape elevation from this file, Mount Bruno elevation.csv, it's a CSV file. And then it creates this data object and the layout, telling Plotly how to plot this object. And then I pass the list of my data objects and the layout to the figure function. And then I plot this figure. And this is what I get. As you can see now, it's three-dimensional, and you can actually spin it in 3D. If you mouse over any point, it will give you its X, Y, and Z coordinates. And you can also, using the scroll wheel, you can also zoom and unzoom, but these are pretty much the only interactions you can have in this visualization. And finally, let me show you a parametric view. So I'm going to paste this code, and I press Shift Return. And this will just display this parametric function, which is given by this formula. So here, again, I'm creating the surface object, the layout, and then the figure containing the list of my data objects, so its surface and the layout, and then I plot this figure, and this is what I get. So it's quite similar to the previous plot, very limited interaction. You can spin it in 3D, you can zoom in and out, and then you can mouse over any data point, and that will give you its coordinates, but that's pretty much all you can do here. So as you can see, Plotly is really easy to use. It's a fantastic package for primarily one-dimensional and two-dimensional plotting. And you can do a little bit of 3D visualization with it. You can run other codes, just simply paste them into a Jupyter notebook. Other codes from the Plotly notes link from the course website. And it will give you a very good idea of how you can create visualizations using Plotly. So because Plotly is not the main focus of this course, I don't really want to spend any more time on it. And next, we'll jump to three-dimensional scientific rendering.